Good morning. It's June 5th, and this is your daily brief in science. Here's everything you need to know. KJ Muldoon, a baby diagnosed with the rare genetic disorder CPS1 deficiency, is showing remarkable progress after receiving a personalized gene editing treatment tailored specifically for him. After enduring 307 days in the hospital due to toxic ammonia buildup linked to his condition, KJ celebrated his discharge with a special graduation ceremony, complete with a cap and gown. Dr. Ahrens Nicholas noted that KJ presented the most severe variant of CPS1 deficiency, which necessitated the rapid development of a personalized therapy. The innovative treatment involved administering a medication containing genetic code aimed at correcting the mutation that hinders the production of a crucial enzyme for protein processing. Developed by a team at Children's Hospital of Philadelphia and Penn Medicine, the therapy employed base editing technology with CRISPR, which minimizes unintended genetic changes. KJ received this groundbreaking CRISPR therapy in February 2025, followed by additional infusions in March and April, and doctors report promising results. While the CRISPR therapy has not cured KJ, it has significantly reduced the severity of his symptoms, allowing him to increase his protein intake and decrease medication dosages. Researchers emphasize that it is still early in the treatment journey, and they will continue to monitor KJ for years to evaluate the long-term effects of this therapy. Doctors remain optimistic about KJ's progress, believing it could pave the way for future treatments for similar cases in other children. The community has come together, raising tens of thousands of dollars through a GoFundMe campaign to support KJ's ongoing medical needs. KJ's mother, Nicole, expressed immense gratitude towards the medical team for providing their family with a chance for a healthier future together, while family and friends welcomed KJ home with signs and balloons, symbolizing the emotional struggle and hope surrounding his recovery. Recent research has unveiled a surprising connection between maternal nutrition and the sexual development of offspring. A study led by Makoto Tachibana from Osaka University, published in Nature, reveals that iron deficiency in pregnant mice can lead to male offspring developing female sex organs, despite having male genetic markers. In the experiments, pregnant mice were administered an iron chelator, resulting in 72 XY embryos suffering from anemia. Alarmingly, some of these embryos developed ovaries instead of testes, highlighting the critical role that iron levels play in sexual development. This research marks the first documented instance of a dietary mineral influencing sex determination, according to molecular geneticist Vincent Harley from the Hudson Institute of Medical Research. The findings suggest that environmental factors, particularly maternal nutrition, can significantly influence sex determination, prompting further investigation into the mechanisms at play. The study emphasizes the importance of the uterine environment in regulating sex determination during early gestation. Nutritional deficiencies can profoundly affect offspring development, raising concerns about maternal health. Iron deficiency not only poses risks to the mother but also potentially influences a range of developmental traits in the fetus. While the study provides valuable insights, the applicability of these findings to humans remains uncertain. Researchers caution that extreme malnutrition could lead to undetected cases of sex reversal. The research illustrates the role of epigenetics in sex determination, showing how environmental factors can chemically modify genetic functioning, particularly affecting the KDM3A enzyme that regulates the SRY gene. Overall, this study contributes to a deeper understanding of how nutritional deficiencies during pregnancy can impact sex differentiation in offspring, with implications that may extend to human development and the effects of maternal nutrition on fetal sex differentiation. Meteorologist John Morales from South Florida is sounding the alarm over forecast accuracy as the National Weather Service faces significant staffing shortages. He points out a nearly 20% reduction in weather balloon launches, which is critical for storm tracking and data collection. Morales has described these staffing cuts as a sledgehammer attack on science, warning that they could lead to a dangerous underestimation of hurricane strength right before they make landfall. The National Oceanic and Atmospheric Administration, or NOAA, is predicting a 90% chance of an above-average hurricane season, with forecasts estimating 17 tropical storms in the Atlantic, including 9 hurricanes and 4 major hurricanes. Several former NWS directors have raised concerns that these cuts could result in what they describe as needless loss of life during this expected above-normal hurricane season. Morales cautioned that without sufficient hurricane reconnaissance flights, forecasters might risk flying blind in their predictions. He cited Hurricane Otis in October 2023 as a clear example of how inadequate reconnaissance data can lead to unexpected storm intensity and disastrous outcomes. Reflecting on his previous confidence during Hurricane Dorian in 2019, Morales contrasted it with his current uncertainties stemming from budget cuts affecting forecasting accuracy. In response to the staffing crisis, NOAA is planning to recruit 126 new staff and is conducting short-term assignments to address immediate operational needs. Morales has urged viewers to contact their congressional representatives to advocate against budget cuts impacting NOAA and weather forecasting. Additionally, the new head of FEMA has added to the uncertainty by humorously claiming ignorance regarding the hurricane season, further undermining confidence in the administration's handling of weather-related issues. Morales emphasized the long-term negative impact these cuts could have on scientific research and disaster preparedness, calling for action against any further reductions. Researchers at Tel Aviv University have made a groundbreaking discovery regarding neutrophils, a type of immune cell that plays a significant role in advanced breast cancer. Conducted by the Gray Faculty of Medical and Health Sciences, this study utilized advanced technologies to thoroughly examine the tumor microenvironment. Specifically, the researchers employed cutting-edge methods such as single-cell RNA sequencing and bioinformatics to analyze the interaction between breast cancer cells and neutrophils. The study focused on breast tissue samples from mice at various developmental stages and conditions, aiming to gain a deeper understanding of these interactions. Validation tests revealed that silencing neutrophils in mouse models of advanced breast cancer resulted in a significant reduction in tumor cell proliferation and blood vessel development. These findings underscore the crucial role neutrophils play in cancer progression, as their silencing markedly decreased both tumor growth and angiogenesis. Additionally, the research highlighted a concerning correlation between increased expression of neutrophil molecular signatures and lower survival rates in women with late-stage breast cancer. Specifically, higher expressions of these neutrophil signatures were linked to decreased survival rates in women diagnosed with stages 3 and 4 breast cancer. The implications of this research could be profound, potentially leading to the development of new drug targets or biomarkers for treating advanced breast cancer. The study, published in Nature Cancer, was led by Dr. Sandra Camargo and PhD student Ori Moskowitz, under the guidance of Dr. Merav Cohen. A groundbreaking study from the University of Cambridge is reshaping the landscape of cancer treatment using artificial intelligence. Researchers have successfully utilized the GPT-4 large language model to identify new combinations of existing non-cancer drugs that could effectively target and kill cancer cells. The team specifically focused on affordable, regulator-approved medications, intentionally steering clear of standard cancer treatments. Among the promising combinations identified were simvastatin, a cholesterol-lowering drug, and disulfiram, which is used for alcohol dependence. Both of these drugs demonstrated significant potential in killing breast cancer cells during initial lab tests. In fact, 3 out of 12 combinations recommended by GPT-4 outperformed current breast cancer drugs, prompting further exploration of 4 additional combinations, 3 of which also yielded promising results. This study represents a pioneering closed-loop system where experimental outcomes inform the AI's suggestions and the AI's outputs guide further experiments conducted by human researchers. The findings highlight the integration of AI into the scientific discovery process, allowing for real-time hypothesis generation and validation based on experimental data. Researchers emphasize that large language models like GPT-4 should be regarded as collaborative tools, enhancing rather than replacing human scientists in the drug discovery process. Professor Ross King noted that this collaboration accelerates idea generation, ultimately speeding up scientific exploration. Furthermore, the AI's capacity to generate unconventional combinations, sometimes referred to as hallucinations, has led to valuable insights that merit further investigation. The research received support from the Alice Wallenberg Foundation and the UK Engineering and Physical Sciences Research Council, underscoring institutional backing for the integration of AI in biomedical research. The findings were published in the Journal of the Royal Society Interface, showcasing the innovative role of AI in drug discovery. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.